about an application you can see in the XXIV booth, because we have developed a robot that can take a picture of a person and then draw it. First, I would like to talk some introduction about this topic. First of all, why did we make a drawing robot? Because it's not a business issue. Generally, we can say that there is an increasing expectation that the people would like to understand what the different projects, the different research, the different technologies like robotics or AI, what is it for, how it's working, what are the purposes, so they can understand it better. And that's why we were asked to find out an easy understand problem which we can solve with such tools. Of course, we wanted to reuse our previous or existing results and not to develop everything from the scratch. The history of the Piktor-o-bot is, let's say, it's at least minimum 3 steps. First of all, it was just an add-on with an existing small robot cell with the erasable white board, when we can have a marker pen, and when a picture was ready, then we clean it, and then another one can be run again. But later, all the visitors wanted to have it, so that's why we developed a portable version. Now we can go to different events like here, and in the current version we have some more advanced version. We have another type of system I will talk about later. It's very interesting that we get a lot of inspiration from the different visitors, especially, for example, for kids, because they ask funny things, and it's often a challenge for us. Of course, there are some unexpected things during in a new place. For example, here we have to ask the building management to switch off a special spotlight because it was so close to our environment that it disturbed the quality of the photo we made. We know that there are other solutions in the literature. They have other features and other limitations. For example, we can draw more people in one, and with the shaded version I will talk about later, it's rather new. We didn't find any similar solution. Okay, so let's talk about some words about the hardware. We have a moving environment with a big box, when everything is inside the PC, the robot controller, cooling things and other things. And on the top we can have a normal UR5 robot. It's a collaborative one, so that's why we are brave enough to run it in such an environment. And also its accessories are commercially available: Robotico, gripper, and torque sensor. We have a board, and we have 2 fixed drawing areas with 2 types of application. We use the background wall because if we would like to draw more people, then even though we remove the background regularly, and it's possible to remove the background when other people are there, but it's not easy to handle. If you would like, there are a lot of people on the picture and you would like to draw some of them and to remove others, so that's why we selected this, much easier. And of course a user monitor that everybody can follow what we are doing. And in the shorter version, this is the torque sensor, the gripper, the special jaws, pencil and pen holders for the 2 types of drawings, and a small industrial camera coming from Germany. And we have a LED light source because we would like to have direct light to the face. It's sometimes very good because the quality of the photo is better. Sometimes it's very bad because when the glasses, there are some unaccepted bright areas we have to remove during the contour generation. So, and also this is the very small picture about the software architecture, and I should say that 4 of them are somehow reuse of previous elements. The USTP 2.1 and the UR-Mover, they are two software we developed earlier or we are continuously developing. They are the base solutions we are using when we are programming the UR robots for many different research and industrial applications. The software we are running, the UR control, is the same as we run in any other versions and any other applications. And within the UR mover, we have a special part of it's written in Java, part of it which is fit the Piktor-o-bot things. We have two additional things: AI-based image processing running in the computer's GPU. Of course, it's rather specific for this application, but anyway, the solution that we are using, AI-based image processing for different robotic applications, that's one of our key issues we are using. And the sequence planning, it's an open source solution developed by some of us. We're using here to have a quicker drawing. Okay. There are a lot of challenges in the application. The first of all is the image processing, but I do not want to talk about it too much because in the previous session my colleague in another room, so not in Braunschweig, but I think in Berlin, he was talking about. But if you go to the booth, you can have a closer view. Anyway, it's a set of different algorithms. Most of them are AI or very simple OpenCV solutions. The other things I will talk about a little bit more detailed. This is the basic sequence I was talking about, but there are some special manipulations which are brand new, so it's not on the picture. For example, outline drawing of hair and eyebrows, because in bad lighting conditions we had some problems with the blonde hair. Sometimes it was skipped. But also we realized just last month that we have to thinning a little bit the eyebrows, because even though if we just draw the contour of it, it seems to be too wide, and it's not nice to see. We have some problems. We had some something handling the closing pattern, because it was often the case that it took much more time if the clothes were too detailed, and some other things. We have a shaded version when we take the picture with a pencil, and we have to fine-tuning the shade boundaries, and also we had some problems with the white spots, because now the white spots is the environment, and if we leave something white inside the face, and if the boundary is at the touches the outer environment, that is very funny that is the same color. So for the face we use some any but gray colors. It's in the robot control point of view, the adaptive speed control of nice lines are very important, because the robot should follow the path which was defined by the generated lines, and the robot's dynamic behavior is something different. We have to follow it, and it means that from a 2D polygon we have to project that to the drawing board, and it's becoming immediately 3D polygons. And we have to calculate the max speed and the acceleration and the deceleration value of the robot. That's why we use the specialty of the UR robot, that you can send every 8 milliseconds a command to the robot where to go, and that's how we use it, that we can follow exactly the trajectory. And it's also very good use if we have a direct force control. We can measure the force, and we can immediately act according to the measured value. We have also have a speed profile because at the end and the beginning of the line the speed is 0 and so on, and even very close to 0 when we have a sharp corner for a special line like this one. This is a red one, that is a very sharp line. And so on. And next one is the trajectory. Then we have, finally we have a lot of lines. And in this picture, the black lines means we must draw it. And we have not too much freedom. Only the free parameter is the direction of the line. But the speed and other values are determined by the quality of the line. So we have to follow these parameters. The blue lines when the robot is moving in the air. So the problem it's call it like the general traveling salesman problem, that you have lines and which is the good order for them, which optimize the timing. We use our Prosecco solver. It's open source. We use it in many other applications, and it runs when the robot grabs the pen and moves on the top of the board. So within a rather short time, we're trying to have an optimized or close to optimized sequence. And of course, it's not visible in this picture, but it's also a movement when we touch the paper and go away to find the next line. And it's the new development just for this event, the force-controlled shaded drawing. We use 4 different colors, 4 different gray colors, and we reach it with 2 pencils. One of them is a 2H and the other is a 2B. And with that, we can play how to rotate the pencil. So finally, the 2H pencil is titled at 60 degrees, and the 2B is directly with 0 degrees towards the paper. And we can set, we did it yesterday, the force value what our pit controller must follow, that to have, as you can see in this picture, 4 rather different gray color. Here we again use this algorithm that in every 8 milliseconds we send the next position for the robot, and that's how we can follow that if the force is too high, then you have to move a little bit away from the paper. If it's too small, a little bit closer, and even though follow the line you have to follow. In this picture we have, in this version we have just polygons, and with a zigzag move we try to fill the polygons, starting from the lighter version and lighter color, and then change the pencil and to the darker. Here you can see one of our colleagues and the 2 versions from the same picture. In this version, there are some issues around the mouse which we solved for this conference, but it was published, so that's I keep it. There is a very funny problem with the transportation, because we have to move it different positions. So our colleague developed a box, and inside the box we have everything, including the equipment, the cooling, and some weights that is not so heavy when we have to put it in a car or things like that. But the real challenge when we have a transportation is the calibration. So that's what we did yesterday afternoon, recording the pickup poses, sensing the drawing areas, scanning the drawing areas, fine-tuning how to pick up the pens and storage. Okay, and we have some software solutions for that. Some conclusions, that this demonstration has been showed more than 60 events, and maybe 1/3 and a quarter of them was outside our institute. This is the second time when we are not in Hungary. First was 2 years ago in the second Stuttgart Science Festival. We were in the town hall and it was very interesting. A lot of German kids visited us. Even though many people can understand it and have very nice discussions, some scientific and industrial relations started from here, that we met people and later we tried to solve their problems. And I am inviting you at the X20 booth, and as I have to have this picture that 4 and 9, we saw that this is the goals which is somehow fit about this application. And thank you for your attention. The first logo shows the Hungarian National Lab. It's a project sponsoring this effort, and the second one is a European one. It sponsors our current trip and how we move the robot to Hamburg. And if any of you are interested in, I am happy to draw him, not me, but the robot at X20 booth. Thank you for your attention.